Welcome to aminacademy.com. In physics formulae and their explanation, let us discuss about formulas of work, power and energy. Work is referred to as the process of energy that is transferred to an object's motion by applying force. Therefore, work is force into distance. Power is W by T. Work by time is power. Power can be written further, P equal to Fd by T. Now, W in vector form we can write work W equal force vector dot into dot S vector, which is further force vector into R final minus R vector initial. Further it is F cos theta also we can write Fs cos theta. Work done by a constant force. A work W done on an object by a constant force is defined as work W equal to F dot D. It is equal to the magnitude of the force multiplied by the distance of the object moves in the direction of the force. So we can write in the vector form here F force vector equal Fx I Fy j vector Fz k vector. This is work done by constant force. This is for variable force. Here, work done by constant force. Here, in that, unit of work is Joule. MK system, work unit is Joule. Joule. And CGS system, work is erg. Therefore, 1 Joule equal 10 to the power of -7, 1 erg equal 1 erg equal 10 to the power of -7 Joule. Note this point. Next one, work done by a variable force. Work done by variable force is a concept in physics that involves calculating the amount of energy transferred when an object is subjected to a force that changes in magnitude or direction as the object moves. Here, this is the curve is that force. Under this curve, if we integrate with two limits, we get work, that is the energy. Here, therefore, suppose force vector equal Fx I cap Fy j cap Fz kk and ds vector is dxi dyj this is a k cap. Then work is integral xa to xb fx dx plus YA, then YB, FY dy plus ZA, ZB, FZ, is that is, it is a combination of these three factors. Next one, area under the force displacement curve. Suppose this is a force displacement curve. Area under the force displacement curve is represent the work done by a force over a given displacement. The area is not in Newton. That is work done in. Here, the graph has force in Newton on the vertical axis and the displacement in meters on the horizontal axis. The area is calculated by integrating the small area elements under the curve. Here, look at here. This force is y-axis and displacement is x-axis. Under this curve, if we integrate, this area tells us as a work done. Here, this is negative work done. That is total work done is this positive work done minus this negative work done. Work done, difference between conservative and non-conservative forces. What is conservative and non-conservative forces? The main difference between conservative and non-conservative force is whether the work done by the force depends on the path on object, how it forms. Conservative force. The work done by a conservative force is independent of the path taken by an object between 2 points. In other words, we can say further explanation, the work done is the same along any path. For example, the gravitational force on a ball thrown into the air is conservative because the total energy of the system does not changes. Though the ball's gravitational potential energy increases as it rises, other examples of conservative forces include spring force and elastic force. These are the conservative forces. Next one, non-conservative forces. The work done by a non-conservative force depends on the path on object X. This path is important for non-conservative forces. Non-conservative forces are also dissipative forces, meaning they take energy away from the system as it progresses. This energy can't be recovered and is converted into other forms like heat, sound, or light. Examples of non-conservative forces include friction, air resistance, and tension in the cord. These are non-conservative forces. Main different here, conservative work done is independent of the path, that is conservative. Non-conservative work done in a round trip is not zero. Work done in a round trip is zero. Work done depends upon the path. Next is energy. The energy in physics is the capacity for doing work. It may exist potential, kinetic, thermal, electrical, chemical, nuclear, or other various forms. There are moreover heat and work. There is energy in the process of transfer from one body to another. These are the energy definitions. That is energy examples also. Now, energy can be classified as a kinetic energy. A kinetic energy is the energy of motion observable as the movement of an object or subatomic particles. Every moving object and particle have kinetic energy. A person walking, a soaring baseball, a crumb of falling from table, and a charged particle in an electric field are all examples of kinetic energy at work. Now, kinetic energy, the formula is K equal half mv square. M is mass, V equal to velocity. Next one, potential energy. The potential energy is the stored energy in an object due to its position, properties and forces acting on it. Common type of potential energy include gravitational, elastic, magnetic, and electric. These energies relate to an object's position or shape and their potential to convert into kinetic energy. Look at here. This is a potential energy and release the arrow is a kinetic energy. Arrow moves faster. Difference between potential and kinetic energy. Kinetic is energy present in the body when it's motion, but potential energy is about its position. It is transferable. Kinetic energy is transferable. Potential energy is not transferable. Measured on the basis of velocity and mass, kinetic energy, measured on the basis of height and mass. Then change according to the change in the speed, change according to the change in the position, and change in the position. Here, K is symbol for kinetic energy, U is symbol for potential energy. Moving car, flowing river, these are the examples of kinetic energy. Branch of tree, stretched rubber are some examples of potential energy. Now, this potential energy equal U equal to potential energy, which is equal mgh, mass into gravity into height. Next, what is the classification in potential energies? Gravitational potential energy. Gravitational potential energy is the energy of an object has due to its position above Earth, energy due to its height. We know that gravitational potential is mgh, where m is gravitation, g is m is mass, g is gravitation, height is h. Elastic potential energy. Elastic potential energy is energy stored as a result of applying a force to deform an elastic object, for example, spring. The energy is stored until the force is removed and the object springs back to its original shape. Here, this is static spring, normal without load. Here we are compressed, a compressed load. If you release the hand, it comes up with force. Then stretched spring, if you release your one hand, it goes down. That is with forcefully it goes down. So it is a elastic potential energy. Gravitational potential energy, GPE, we have elastic potential energy is half kx square. Energy is half kx square, where k is a spring constant, x is a distance mode, distance extended or distance compressed. Relation between potential energy and conservative force. The relationship between potential energy and conservative force is that the change in potential energy in a system is equal to the negative of the work done by a conservative force acting on an object in the system. Here, first is U is a function of only one variable, that is F4 equal minus du by dr. That is this is the formula for the relations between force and conservative force. Relationship between potential energy and conservative force. Du by. Next is another case, F equal dou u, that is partial derivative with respect to x, I vector plus dou u by dou y, j vector, dou u by dou z, k vector. Next, work energy theorem. What is work energy theorem? The work energy theorem states that the total work done by all forces acting on the object is equal to the change in the object kinetic energy. The equation of the work energy theorem, W equal kF by Ki. First, K1 is, K initial is half mvi square, initial kinetic energy. K2 equal to half mvf square, that is final kinetic energy. Then by using work energy theorem, W equal to K2 minus K1. Next is power of a force. In physics, power is the combination of force and moment. When forcefully objects move, it called power produced. It can be defined as the rate of doing work on over time. Within the time, how much work is done is called a power, or the energy used per unit of time. The relationship between power, force, and energy is given by formula. We have first average power. First, average power is total work done over total time taken. Total time taken to work. Total time taken. That is W total by T time. Next is instantaneous power equal rate of doing work done, that is dW over dt, which is equal F dot V vector, which is equal FV cos theta. Next one, vertical circular motion. Look at here, this is a vertical circular motion, that's it's rotate, the bob is rotate vertically from fixed point. Consider a tiny body with mass m that is swilled in a vertical circle with radius t given one end of the spring. The body's acceleration rises as it descends the vertical circle and decreases as it ascends the vertical circle. If you go up, acceleration is reduced, and it come down, acceleration is increasing. As a result, the body speed is constantly changing. It reaches its maximum at the bottom of the vertical circle and its minimum at the top. As a result, the body does not move circularly. The weight mg always operates vertically downward regardless of where the object is on the circle. That means object position anywhere else in the circle, but its body weight is always vertically downward. Now, the condition u. If initial velocity, if u is velocity of the object is greater or equal to square root of 5 times gr, what happened? The bob will complete the circle. The bob complete the circle. Then another condition, if square root of 2gr is lesser to velocity and lesser to 5gr, under this condition string will slack. String of the bob will slack, loosen. Then another condition, if u is lesser or equal to 2gr, what happened is Bob will oscillate between Bob will oscillate between Bob will oscillate between this one side of the circle, like between half circle. Further, if u equal exactly square root of 5gr, where r is the radius, Bob will just complete the circle. It's not necessarily done. Next, at height h and height h from the velocity v equal q squared minus 2gh. Therefore, now we can say under square root of 2gr is u under square root of 5gr. Then cos phi. This angle cos theta here equal q squared minus 2gr over 3gr v. When u is greater or equal to 5gr, what happened in this condition? Total tension at point A that is at, we can put this h at h, total tension at the downward point, that is at L, then the same then T equal total tension T equal 6 mg. Tension at higher point H, that is T H equal 3 mg. So far we discussed different formulas for energy, work and expression for velocity of body moving vertical circles. We have done. Please subscribe our YouTube channel.